Let's quickly take a look at this simple PERT problem. My plan is to show you a full solution cycle from beginning to the end. Okay, so I picked a problem from your textbook. This is 318. This is a basic description. I added the preceding activities so that you can develop network diagram. Therefore, you can have this full flavor of what this type of problem is going to look like. Okay, so basically, those are the steps I'm going to take. So I'm going to take those steps one at a time. So a key question here is I'm trying to answer those two problems, those two questions. Number one is, what is the probability of completing in 80 days? What is the probability of completing in more than 60 days? As you may recall, in order to answer those two questions, you need to know what is the expected duration and the standard deviation of the critical path. So eventually we need to get there. Okay, so how do I get there? I'm gonna help you to take those steps one at a time. So first you need to find out what is the expected duration as well as the variance for each activities. Okay, each activity. As you may recall, the expected duration is the weighted average with optimistic plus 4 times of your most likely plus your pessimistic estimate. You divide it by 6, and your variance is the difference between the pessimistic and optimistic divided by 6. This will give you a rough estimation of the standard deviation because the variance is the squared of your standard deviation. So I'm going to do this. Okay, so now we have expected duration and the variance for first activity, and you just need to drag it to fill the rest of the areas. So now we have expected duration and the variance for each activity on your table. Then next thing you want to do is you need to identify the critical path. So how do you identify the critical path? So in order to identify a critical path, you need to translate the table into what? Into a network diagram. So for this part, I'm gonna skip it. You can just pause and see whether this is a diagram you will be developing if you are to complete this on your own. Okay, so as you can see, path ACEF has the longest path. So our critical path is going to be ACEF. Okay, so in this diagram, I have completed both forward passing and backward passing. If you are just solving a network diagram, in order to identify the critical path, you don't have to finish the full cycle. You just need to complete the forward passing. Of course, if your questions involving the slack, you may have to complete the backward passing as well. But I just want to remind you, in this case, I just need to identify the critical path. So forward passing is all you need, okay? But I finished anyway. So ACEF is going to be the critical path. So I'm just going to list critical path is ACEF, okay? So for my critical path, I need to know the expected duration. For your critical path, you need to know the standard deviation eventually. Okay, standard deviation. But you cannot go there directly. You must calculate the variance before you jump to the standard deviation. So for ACEF, the expected duration is the sum of all the activities, sum of all the expected duration for the activities involved. So it's going to be A, C, E, and F. Okay, that's your expected duration for the critical path. It's gonna be roughly 70 days. And your variance is gonna be the same calculation. You're gonna put together the variance. The variance of A, variance of C, the variance of E, the variance of F. Okay, so you may be wondering why this has variance of C. It basically means that there is no spread. There's no turbulence with regard to the with regard to the activity C's variability, because it's optimistic, most likely, pessimistic. They're all 18s. Basically, this means that activity C will be done in 18 days. There's no variability in there, okay? And then standard deviation is basically the square root of your variance. So with that, we have expected duration and standard deviation ready for our questions, okay? So first question. So at this point, we finished all the way until step 3. So step 4 is basically finding out the desired probability using norm-dist formula. Probability of completing in 80 days. So how do you find it out? I'm going to show you. It's important you kind of visualize in your mind before you jump into use the formula to get the answer. Okay, if the expected duration is 70.17 and standard deviation is 1.74, and you want the area all the way up to 80s, okay, so all the way until 80s. Okay, that basically means 100%. The reason why we're seeing this is because the standard deviation is fairly small when compared to the average. Therefore, it's not a very turbulent or volatile project to complete. So let's tweak our question a little bit. Say, what about 72 days? Okay, let's go back there. Let's change this to 72 days. Okay, now it's easier to recognize which area that you're looking for. So what is the chance that we can finish in 72 days? It can be 70 days, it can be 68 days, it can be 66 days, it can be 67 days. Okay, so you need to consider all the scenarios as long as that scenarios involve the duration that is shorter than 72. So as you can see that this little tool tells us it's going to be roughly 85%. Okay, let's see if we get the same result. Pretty sure we'll get the same result. Our x is 72, our average, our standard deviation, last parameter is always true. Okay, so I think we got exactly same result here. So next one is completing in more than 60 days, completing in greater than 60 days. Again, let's visualize this, okay? Visualize this. It's the same distribution. This time it's 60, but it's after the 60. Well, as you can see that because we have a very small standard deviation, therefore 60 is way to the left. It's a bit difficult to recognize. Again, let's change our problem a little bit. Let's say 68. This should have a slightly better visualization. Now you can see that we're looking for the area that's beyond 68. We need to consider all the scenarios that has a duration that is longer than 68. It could be 69, 69.5, 70, 71, 70. All scenarios must be considered. Therefore, we are looking at the anywhere beyond 68. Okay, so for that one, if you recall, you need to use 1 minus norm dist. Our x is 68. Our expected duration is still the same number. Standard deviation, same number. True. This is going to be the probability. Okay, so this is a full cycle for a PERT problem. You may have a longer list of activities. You may have much more complicated network diagram, but essentially those are the 4 steps that you need to take to complete a PERT problem. Okay, thank you. I'll stop here.